Okay, so now that we've practiced pretty much all of the factoring methods that we did back in September or October, we're going to get into something called substitution factoring, which we actually did earlier in the year, but I do remember it being a little bit confusing, so I just wanted to do a day where we practice that, because you can factor like more complex polynomials by doing that. So substitution factoring, it says sometimes a polynomial can be factored by substituting one expression for another. This is used when polynomials begin to get a bit complicated. So if you're looking at something that I ask you to factor and it looks like it's a lot more than usual, you're probably going to end up using substitution factoring. If we continue, by substituting expressions for one another, it allows us to turn a complicated polynomial that is of a form we may not know how to factor into a much more manageable polynomial. Okay, so your steps for this: the first step, you are going to look at the middle term to substitute. Second step, once you look at the middle term, I'll go over that in a second, but once you look at the middle term, you're then going to write a let statement and substitute that new variable. You obviously, if you're substituting something with x's, don't write let x equals. You have to change the variable. That's why I typically use, I typically use u. Most of the time you will use u. If you go up into calculus, they have something called u substitution for something that you're going to learn about in calculus. But typically you're going to see u being substituted in for that expression. Third step, you're going to factor the new expression, or the new polynomial if you want. Factor the new polynomial with your new variable. Once that's factored, you're going to substitute back. Substitute the previous term back in. Previous term back in. And then lastly, you are going to simplify if possible. And you want to make sure it's completely factored. So simplify if possible and factor further if possible. You want to make sure if there's a GCF that it's pulled out. If you can do the difference of two squares, if you can do, just make it better. You can do master product, whatever it is. Okay? So let's look at some examples of this. So number one, if we're looking at this, we have 2x to the 6th minus 13x to the 3rd minus 7. Right? So if you're looking at this, this does look a little bit more complex because you have the x to the 6th and the x to the 3rd. So the first step is to look at the middle term to substitute. You are going to look at the middle term without the coefficient out front. Ignore the coefficient. So you're going to look at that x to the 3rd. And this is what you're going to do. If you square x to the 3rd, you get x to the 6th, which is that first term, right? X to the 6th. So that's going to work. So because this works, your let statement, you're going to write let u equal x to the 3rd, and u squared is x to the 3rd squared, which we just said is x to the 6th. Okay? Because this and this match up, because x to the 3rd squared is x to the 6th, you can do this. Okay? If that were x to the 5th out front, then you would not be able to. So if I substitute this stuff in, I have 2, instead of writing x to the 6th, I have u squared minus 13. Instead of x to the 3rd, I have u minus 7. And now you have a normal master product situation. So you multiply the first times the last, you get negative 14u squared. Two numbers that multiply to be negative 14 but add to be negative 13 would be negative 14u and positive 1u. So this is now 2u squared minus 14u plus 1u minus 7. You split this in half to do factor by grouping. You take out a 2u, and you're left with u minus 7. On the other side, GCF is a 1. You're left with u minus 7. U minus 7 comes out. You have left 2u plus 1. That was step 3. Factor the new expression. Step 4 is substitute the previous term back in. I asked you to factor an expression that had x's in it. Your answer should not have u's. So now you're going to substitute it back. So u is x to the third. So this is now x to the third minus 7. And this is 2x to the third plus 1. There's nothing further that I can simplify, nothing further that I can factor. This is my answer to number 1. Okay, number 2. So I look at my middle term without the coefficient, without the 5, and I have x plus 1. So I take x plus 1 squared, and I have to see, is that equal to the first expression that I have, which is x plus 1 squared? So it works. So because this works, you're going to write your let statement. So you're going to let u equal x plus 1, which is the middle term. If you want to put it in parentheses, you can. And then u squared is x plus 1 squared. Okay, so now we plug this in. So instead of x plus 1 squared, we have u squared minus 5. Instead of x plus 1, you have u, and then minus 12. And then again, a normal master product. So we have negative 24u squared. Has to add to be a negative 5. That's going to be negative 8u and positive 3u. So this is 2u squared minus 8u plus 3u minus 12. Split it down the middle. 2u, u minus 4. Over here we have a 3, left with u minus 4. So u minus 4 comes out, and you have 2u plus 3. So now we substitute it back. So we have x plus 1 minus 4, and then 2x plus 1 plus 3. So again, this is really x plus 1 minus 4, and this one is 2x plus 2 plus 3. You have to simplify, right? So you have to do this part. So this is going to be x minus 3 and 2x plus 5. And that's it. You cannot factor that any further. So that's your answer for number 2. Number 3. My middle term without the coefficient is x squared. If I square x squared, I get x to the 4th, which is my first term. So it works. So you're going to let u equal x squared, which means that u squared will be x to the 4th. Okay, so we have 4u squared plus 7u minus 2. Now you do master product. So we have negative 8u squared. It has to add to be 7, multiplied to be negative 8. So you're going to have 8u and minus 1u. So then this will be 4u squared plus 8u minus 1u minus 2. Split it down the middle. On the left side, you can take out a 4u, and you're left with u plus 2. On the right side, negative 1, left with u plus 2. The u plus 2 comes out. You are left with 4u minus 1. You substitute it back. That would be x squared plus 2, 4x squared minus 1. You can't simplify this any further. However, 4x squared minus 1 you can keep factoring, right? That's the difference of two squareds. 4x squared is a perfect square, 1 is a perfect square, and you have subtraction in the middle. So this x squared plus 2 you leave alone. And now you have two binomials. The square root of 4x squared is 2x. The square root of 1 is 1. You get 1 plus, 1 minus. That's your final answer. And then last one, number 4. 3x to the negative second plus 11x to the negative first minus 20. So again, you look at the middle term. If you square it, you get x to the negative second. So it works. You're going to let u equal x to the negative first and u squared equal x to the negative second. The whole purpose of doing this is so that it gets rid of all of that ugly stuff and it looks like something that we've done before, like we did the other day with just regular master product, but instead of an x, you have a u. So this is 3u squared plus 11u minus 20. Master product is negative 60u squared. Two numbers that multiply to be negative 60, add to be 11, are going to be positive 15u, negative 4u. So we have 3u squared plus 15u minus 4u minus 20. Split it in half. 3u, u plus 5, negative 4, u plus 5. The u plus 5 comes out. You're left with 3u minus 4. And then you substitute back. So this would be x to the negative first plus 5, 3x to the negative first minus 4. Now, technically this can be your final answer because I don't specify how I want my answer. But let's just say I don't want to see any negative exponents because we know a lot of the times we don't want to see negative exponents. X to the negative first, if you remember, the negative exponent, right now it's in the numerator. It doesn't like being in the numerator because it's negative, so it switches. It goes down to the denominator to be a positive 1, and there's nothing with it on the top, so the top is a 1. X to the negative first is 1 over x. Same thing over here. This x to the negative first, right? We used to circle them. This had a 1 here, and then it goes to the bottom. So x to the positive first, and then a 3 in the top. And then you have minus 4. So that's your final answer. Or technically you can leave what I had right before this, but just wanted to make sure that we understand that. Okay? Let me know if you have any questions. Upload your notes. Homework just like this will be up tomorrow. Have a great day.